Welcome everybody to this Oceanology International 2020 session on marine pollution modelling and monitoring. We have a brilliant array of speakers for you today. We have Paul Taylor, who's going to be talking about modelling and data management systems and predicting marine pollution, our first speaker. He'll be followed by Stephanie Lavelle, who is going to be talking about monitoring marine plastic pollution. And finally, we'll be finishing up with Phil Johnston, who is going to be talking about the ocean cleanup and monitoring using an Autonaut ASV. So our very first speaker this morning is Paul Taylor. Paul Taylor is a principal consultant and modelling lead for Intertech Energy and Water Consultants. He has a huge amount of experience in marine, coastal and estuarine environmental consultancy, and I'm sure he's going to deliver an absolutely brilliant talk. So Paul, over to you.
Thank you, Bev, and good morning, everybody. It's a privilege to be able to present again at Oceanology this year, albeit under different circumstances to what we might have all expected, but an honour nonetheless. As Bev said, I lead the numerical modelling team at Intertech Energy and Water, and we're environmental consultants that work across lots of sectors in the marine and offshore environments, as well as coastal and inland waters. And today I'm going to be talking about how models and data management systems can be used for predicting marine pollution. I'm going to begin with an overview of the issue, and I'm talking about water quality in coastal waters, primarily bathing waters, and how these can be managed and mitigated. And I'll move on to a range of models and data and systems that can be used for predicting poor water quality, so that we can then give adequate warnings to people that use the water, so bathers and other recreational users of our beaches. And I'll finish with some examples of some operational systems that have been up and running for a while. I'd like to make a couple of acknowledgements to some colleagues. So Richard Dannett, who works with me and has been instrumental in developing and implementing some of these systems I'm going to talk about, as well as Professor David Kay at Aberystwyth University, who's kindly provided a little bit of his research that I'm going to touch on today. And I'd like to thank 4 of our key clients who have kindly given permission for me to reference their work. So that's Anglian Water, Yorkshire Water, Welsh Water and Southern Water. So talking about pollution of coastal waters, and as I said, it's water quality that I'm referring to here. And the biggest cause of water quality issues are human beings. It's our society that generate it. So as our towns and cities grew and before implementation of modern sewer systems, water quality was terrible and public health issues were rife. Lots of outbreaks of cholera and things like the Great Stink in London. And this led the Victorians to develop some fantastic sewage systems, a feat of engineering that really helped improve the water quality and thereby public health. And it was fantastic. And a lot of those systems are still in place today. There's been ongoing investment in the infrastructure, though, specifically over the last 20 or 30 years, with new long sea outfalls and pumping stations, improved treatment processes like UV disinfection that kill off a lot of bacteria prior to discharge, and big infrastructure projects like the Thames Tunnel system that is aiming to collect more of the sewage and transfer it for treatment, such as the photo on the bottom right there. But most of our cities are still left with the legacy of the systems that the Victorians put in place, and fantastic as they were, they are getting old, and they were also combined systems. So what that means is that there's one network, one pipe network that collects all of the sewage from our homes, but also rainwater runoff from roads and gullies and so on. So when it's raining, the system can fill up and become overcome. And that can lead to 2 things. Either it backs up and spills through your toilet into your bathroom, which nobody wants, right? Or we relieve that pressure through an overflow, combined sewer overflow, which prevents flooding, but it also leads to discharges of diluted but untreated, effectively sewage, mixed with rainwater. So you do get a deterioration of water quality when that occurs. And they can be not insignificant. The picture on the bottom right shows a CSO in operation under heavy weather. But our coastal waters and lots of our other water bodies as well are protected by different legislation. So there's a number of EU directives that are in place, at least for the time being, although I think they will remain in force for at least a while yet. Specifically in the coast, we have Bathing Waters Directive that protects our beaches, the designated beaches, and what was a Shellfish Waters Directive is now under the Water Framework Directive, which is a broader directive that covers lots of water bodies, but the Shellfish Water Directive to protect designated shell fisheries for harvesting. Now, these directives are there primarily to protect human health from people getting ill from either eating shellfish or ingesting poor water quality when they're in the water, swimming or using the beach. So we use bacterial indicators, fecal indicator organisms or FIOs that are in poo, and they might not necessarily be harmful themselves, but they're easy to detect, relatively easy to detect and measure. And we use those to identify the presence of what might be quite harmful pathogens or bacteria that would make people ill. And the authorities, that's regulators and local councils, aim to improve the long-term water quality of water at our beaches and shellfish waters. And there's an ongoing program of work to try and to do that, but also to manage the use of the beach on a day-by-day basis through providing notifications and warnings when there might be poor water quality. But it's a complex system. There's obviously the point sources that I've referred to from the sewage system, not just the overflows, but also the long sea outflows that discharge continuously treated effluent. But there are other point sources from other industry. There's runoff from agriculture, lots of livestock in upstream catchments, that animals that defecate, and that gets into ultimately into the watercourse in different ways and down into the sea. And other diffuse sources, so seagulls, big populations of starlings on piers, dogs, horses, whatever. All these animals produce bacteria that contributes to that E. coli. They might not necessarily be harmful to humans, but they contribute to that E. coli and enterococci indicators. So it's a complex system and difficult to predict. And the reality is that water quality at the coast varies significantly throughout the day, regardless of how the sources are changing. There's lots of factors. I mentioned David Kay and his colleagues at the Centre for Research into Environment and Health, who also advise the World Health Organization on these topics. They've undertaken lots of research, which involve a lot of data collection, intensive data collection in specific sites. And they produce lots of papers. I can send you links to them, but here's one of their most recent ones. And in that, there's a lot of data and data analyses, and I'm just going to draw out some of that. So what this graph is showing on the left are samples of E. coli on 2 different days at one point at a beach or near a beach. And the graph shows that varies by orders, a couple of orders of magnitude throughout the day. And it's the same for enterococci, and they see the same thing wherever they go. Not exactly the same pattern, but a diurnal variation in quality. So currently the regulators, they collect samples once a week throughout the bathing season in order to determine the compliance with the directive and classify the beach. I mean, it's not even really good enough for that job, but it's certainly not good enough for producing a short-term prediction, which is really what users of the beach need. They don't need to know what was the classification of the beach last year. They want to know what's it going to be like this afternoon. I want to take my children to the beach today. So we need to be able to accurately predict what the water quality is going to be doing throughout the day, because it changes. And those changes in data on quality would lead to a classification that varies. This is at a beach, I can't remember the name of the beach, but from poor in the morning, it gets to sufficient, which is the minimum standard the directive needs, getting to good just about just after lunch. We're really aiming for excellent everywhere. And it drops back down through sufficient to poor. And this is driven by sunlight. Sunlight kills bacteria. That's a primary decay influence. And so the sources might be the same, but the sunlight itself is leading to this variation. So talking about what systems are available, there's a number around the UK and elsewhere in Europe and abroad, varying their complexity. From a simple tin sign on the beach, I'm pretty sure this is in Australia, I think it's Manly, but it might not be, it might be a different beach. There's just a tin sign that says that if the sign's wet, don't swim because it's raining. That's quite effective, but it doesn't help you plan your day, right? You get there and it's too late. There's many more sophisticated systems. So SEPA have developed a decision tree system that takes in lots of different data, and it works through a decision tree to come up with a likely water quality, and then they can provide warnings through electronic signs, like at Portobello at the bottom right there is an example of that gives a warning. The English Environment Agency have developed a similar system based on correlation of rainfall, and they've looked at lots of different types of correlation and information in order to provide as best a warning as they can at a number of beaches. But it doesn't work everywhere, and it's been developed continuously and improved on. There are black box systems. So these are data-driven models that are based on lots of data collection, like the data that I showed from David Kay's work. And there's some systems in place at Swansea Bay and a couple of other sites in Wales that are really effective, but they're very data hungry and they cost a lot of money to implement. And if anything changes in the system, that black box stops working. You've got to go and collect some more data again. And then there are some real-time sophisticated models that have been run, hydrodynamic and water quality models being run in real time at a number of places around the world. Copenhagen is an example. And they all have their pros and cons and different costs and benefits. What I'm going to be talking about are management systems that we've been developing that utilize a range of things. So they use models, they use databases, forecast information, and real-time data feeds to give a really pragmatic and practical and effective system. Why we've started doing this is because we already had a lot of models and data there, being collected for different purposes. So most of the water utilities companies in the UK have been adopting modeling approaches to help them understand the situation in order to develop targeted investment strategies for the long term, so that they're investing in the right places. So they've invested in developing models and collecting data. So we now have lots of quite sophisticated models that cover the sewage system, river catchment systems, and the coast and estuarine environments. And hand in hand with that, a large-scale data collection program that's given us a lot of data. And things have been continuously improving. So we've got faster machines, so we can run bigger models more quickly with more scenario testing. We've got better software that represents the real world more effectively, and it's easier to use for and more flexible. As I've said, we've got lots more data, so we can characterize our inputs much more accurately, and we can calibrate and validate those models with more confidence because we've got more data and lots of free data now that never used to be around when I started building models. The EA has published all their LiDAR for free, which is fantastic, and we've got longer records of measured rainfall, so we're not having to use models of rainfall, for instance. And we've got better techniques for then taking all of that data and turning it into useful information and knowledge to be able to then make decisions on. So post-processing tools that we've developed and web-based visualization techniques and so on. And ongoing research that's continuously providing us with more understanding that enables a better understanding of the system as a whole to give us, to allow us to make more appropriate and effective management strategies and decisions. I couldn't talk about modeling without showing a model in operation. So I appreciate not everyone will be a hydrodynamic modeler, but this is a model of Swansea Bay. It's running quite quickly. So what we're seeing is the tide sloshing in and out. So those plumes are from two long sea outfalls discharging treated effluent, plus bacterial loads coming down the rivers that drain into the bay. And we see things starting to change now. Things are getting, so red is not so good and blue's good. So what we've seen there is it started to rain, the river loads have increased, the works has reached capacity, CSOs have started spilling, and it's led to a big blob of red that's sloshing about in the bay. It's impacting at the beach. But you definitely wouldn't want to be swimming at that time. But it quite rapidly disperses and decays and gets back to normal. And every rainfall response will be slightly different. Depending on when it occurs, the tides will be different. It might take the impact away from the beach initially, and by the time it's returned, it's actually decayed. Different environmental conditions will all affect what the actual water quality is. So it's not a simple thing to just say, it's raining, my CSO is spilling, therefore the beach must be poor. Might not be. Might be, but it might not be. So what we've done is we've taken these models. So on the left-hand side, we've got our coastal models, and we've run that in advance under thousands of different conditions. So we can build up a really big database of responses that would occur, kind of a source to receiver relationship, really, under lots of different tidal and environmental conditions for all of our potential sources. And we can pre-run that, might take a few weeks, and have that ready. And often that's already there from the work that's been done by the water companies for their longer term strategies. We can take the sewer network model and run that under at least 10 years, probably longer, of different rainfall conditions and antecedent. That's a kind of how dry or wet it was before it started to rain, to get a response of the sewer system to different rainfall. And then we can bring in our forecast data. So primarily it's rainfall, and with weather radar, that's getting better and better all the time. But we also need things like wind conditions, sunlight, intensity, the decay, and tidal conditions, which are easy to predict. And the system then takes that information, it matches the predicted rainfall with the best rainfall that's been pre-run through our sewer network model, finds the response, looks at the timing of that, gets the right impacts from the coastal database, integrates the two, and rapidly gives you a time series of impacts over probably the next 3 to 5 days, that kind of time scale, to enable predictions and warnings to be given. And there's a number of systems in operation now that have been developed. So we built the first one for Anglian Water. They call it their beach aware system. That's driven just by telemetry, actually, so actual spills rather than forecast. So it's more reactive than predictive. But Yorkshire Water have a system that they run with radar data, a similar, but it's more of an information system for Welsh Water that utilizes a lot of data through a web tool. And a system for Southern Water that is very similar to the Yorkshire Water system, which has just been trialed by Southern Water currently, that uses forecast data. Just a bit of detail on the Yorkshire system, because that's the one that's perhaps been running longest. It runs every morning, it gets its forecast, there's about 20 beaches, and it runs through the whole thing in about 15 to 20 minutes, much quicker than you could possibly run a model in real time. And it presents all the information then through a dashboard, so the user can see each beach, its classification, and it can then, the user can start looking at the information, what the antecedent conditions were, and what the forecast is. So this is showing the rainfall that was used to the bar graphs, and then the red and blue or purple lines are the predicted time series of impacts of E. coli and enterococci at the beach over the next day or so. And then if that breaches a threshold, whatever that might be set at, to start interrogating that. We've run all of the various sources independently and then added them together. So you can start looking at the source apportionment. What are the contributing sources to that impact? And then not only does that enable, in this case, the water company to manage that and inform the regulator, and it helps with their PR. Sometimes they are the cause, sometimes they're not. But it also helps people make the right decisions on what mitigation techniques are going to be most effective. And oops, sorry. So we have these systems. They've mostly been built on stuff that's already there. So we've added value to the investment that the water companies have already put in. So they're relatively quick to put in place, and they're scalable and modular. We can add more runs to it, we can build up the databases, we can add functionality as well if we wanted to quite easily. So as well as warning systems, we can start using the tools for contingency planning and consequence analysis. We built some rapid response tools for specific incidents that might occur if an asset fails completely. And then there's some dynamic consenting and management, which really is a discussion in its own right and needs a change to permitting and consenting, but it enables that to happen going forward. So in conclusion, managing water quality at beaches is very complex. There's lots of different sources and factors, but the management systems that I've presented use existing models and data plus real-time info and forecasts to help us improve short-term predictions in order to protect human health. That's the primary driver, but it helps us to understand the key issues which enable us to then better mitigate that pollution, ultimately better manage the assets without just building new assets all the time or bigger holes in the ground to stop those spills, which has its own impact. And in the long term, improve water quality and ultimately protect the environment. Thank you.
Thank you, Paul. That was absolutely fascinating. And as someone who likes paddleboarding and swimming in the sea, it's really comforting to know that there's some organisations out there doing this advanced modelling and keeping us all safe when we're swimming in the sea. So I will next hand over to Stephanie Lavelle, who is going to move on to plastics. Stephanie is currently the project director of the Sea Sanctuaries Trust, a UK-based charity that has helped marine conservation efforts in Indonesia for over 10 years. She's looking at the environmental impacts of marine plastic pollution, and also as part of that work, she is chair of a special interest group close to my heart, which is the I'm Arrest Ocean Plastics and Marine Litter Special Interest Group. So Stephanie, over to you.
Thank you very much, Beth, for the introduction. And yes, thank you very much for the invite as well to speak at OI. It's a real honor, and I'm looking forward to sharing this presentation on looking at monitoring plastic pollution. Plastic is a huge, complex and global issue. And monitoring is really at the heart of aligning academia and governments and industries towards developing circular economy and minimizing inputs into the ocean. So this presentation will give a summary of the global picture that monitoring has helped us build up of plastic pollution. Some of the insight into some studies that have specifically looked at monitoring and modeling. And then we'll briefly explore how methods are being developed to help advances with technology and policy towards circular economies. So despite being found absolutely everywhere, there are still gross uncertainties when it comes to plastic waste budgets. Monitoring methods are continuing to evolve with advances in remote sensing and more refined field and lab sampling to help us understand the global flow of waste, as ultimately we need to be able to measure it in order to manage it. This summary here was compiled by AWI in Germany of over 1,000 publications monitoring global litter from over 50 years, which demonstrates the huge global effort that has been put towards monitoring plastic, but we really still have a long way to go to drive industry and policy in the right direction. Collective and continuous data is important to help understand the sources, sinks and distributions, but it can also help us develop traffic light systems to reduce leakage and help identify best practices for industries and technologies. And it's also really good for raising awareness, which is ultimately what's really driving policy change. So one of the biggest questions around plastic pollution is how harmful is it to human health and ecosystem health? And despite a growing base of evidence on contamination of air, soil and groundwater processes, it's really the impacts in the marine environment that have received the most public and scientific concern. It's obviously a very visual problem, and we know it's harmful to hundreds of species. However, the ecosystem level impacts are more difficult to assess with so many other human influences. As Bev mentioned, one of the projects I'm currently working on is investigating the potential for floating macroplastic to impact the biochemistry of the food web by assessing lower and higher trophic level organisms' response to floating plastic pollution. Thousands of chemicals have been identified in plastics, but there's no existing framework for the monitoring or management of these upstream plastic processes. Some individual chemicals, such as PCBs, have been banned, but can still be found in products today as they're very persistent and get back into the stream through recycling. Micro and nanoplastics are also of more recent concern. Nanoplastics have been found to have the potential to cross the brain and gastrointestinal barriers. And they've also been found absolutely everywhere, but because of their small size, they're very challenging to study. And biomes also quickly become established on plastic when it's exposed to the marine environment. And potential ecosystem level impacts, such as being a vector for pathogens and harmful algal blooms and invasive colonizers, have also been speculated, but not studied in any details to date. The scariest thing we know about plastic monitoring data is the growth of production that's expected over the next few decades. We're currently producing over 300 million tons, which is around equivalent to the human population by weight. And this is expected to double or triple in the next decade, reaching over 1,500 million tons easily by 2050. Over half of what we've produced is single use, and less than 10% has been sent for recycling. And most can only be recycled once. And this, oh, sorry, I haven't moved on to my slide here. I'm using two screens. So yeah, you can see from this diagram here that we've recycled, a very small fraction of what we've produced. And we're expecting a huge growth of production over the next few decades. And this data here also from the plastics economy shows that the biggest growth that we're expecting is in the Middle East, Africa, and Asia, where there's an expected packaging boom. With their expected growth in economies. Jenna Jambeck, she did a very famous study with a group of people that assessed easily 4.8 to 12.7 million tons are entering the ocean every year. So that could quite easily be over 1 million tons a month entering the ocean. And this is expected to triple by 2040. So Asia and Africa are definitely some of the most critical hotspots, but rivers are also a hugely under-considered input as to leaching from these areas that really have next to no waste infrastructure. And by 2040, there's about 4 billion people that are expected to be without a waste system. There was the controversy in it is that countries in America and Europe actually have substantially higher plastic consumption per person. But we definitely have the lack of waste infrastructure issues in Asia and Africa. One study recently found that these rivers highlighted here are some of the biggest polluting rivers in the world. Out of around 56 rivers assessed, I think, they found these tend to transport 90% of the plastic out of that assessment into the oceans. But a more recent study has actually assessed that small urban rivers are amongst the most polluting. But even in Europe's largest river, the Danube, plastic has been found to outnumber larval fish. So yeah, although countries in Asia and Africa have been identified as some of the biggest contributors, the issue is far more complex than this. And something that's often overlooked is the export of plastic waste from high-income countries, as low and middle-income countries have really been used as dumping grounds for decades because of their lack of waste infrastructure and regulations. Another hugely under-considered aspect of plastic pollution is the impact on climate change. Some models predict that plastic life cycles could be contributing up to 20% of our CO2 emissions by 2040. But either way, the annual emissions associated with plastic production already exceeds the output of most countries. Over 200 billion has been invested in plastic and chemical projects in the USA alone since 2010. And in 1 year, the investments into the petrochemical production facilities grew by more than 25%. And Judith Enck, the founder of Beyond Plastics, said if even a quarter of the ethane fracking facilities that are currently in the permitting process in America are fully invested in, then it's going to lock us into a plastic future that's going to be very hard to recover from. So we're looking at monitoring marine plastic pollution, macro plastic pollution in the ocean. It's very broadly split into land and ocean-based sources. So we know that around 75% of land-based sources comes from uncollected household waste. It's about an 80-20 ratio from land-based versus ocean-based sources, roughly. With around 25% of land-based sources coming from within the waste system itself. As you can see from this waste atlas developed by Leeds University, highlighting the 50 biggest dump sites in the world, many of them are coastal and are at risk of further coastal erosion and weathering from climate change. Even in the UK, there are around 20,000 historic landfill sites that had few regulations in place at their time. And one study has found that easily 5,000 lie in areas at risk of flooding and coastal erosion. So it's very much a problem in the UK as everywhere else. We have had a lot of good information provided to us from citizen science and NGO projects. As we can see, cigarettes and packaging, which is often branded packaging, are some of the biggest contributing industries. This academic paper also highlights, packaging is very clearly one of the major contributing industries, but also we have fashion and textiles industries, and automotive and agriculture and other consumer products are all influencing land-based sources. And so ocean-based sources, they refer to waste from the shipping industries and fishing. And these are found to correlate with local activity, so shipping lanes and high fishing areas. And this study that was done in 2008 found that in the area known as the Pacific Garbage Patch, they found that nearly half of the floating plastic waste to be made up of lost and abandoned fishing gear. And a study that was also recently done in the small island of Aldabra in the Seychelles, actually a good friend of mine working at the University of Oxford was on this project, and they managed to assess that about 500 tons of waste were on this small island, one of the highest amounts recorded for a small island that's obviously having no input into this plastic waste. And they found that over 80% of this was estimated to be fishing gear. They managed to remove 25 tons of plastic from the island, and they also did an economic assessment on this and found that it was costing over $8,000 per ton to remove the plastic from this remote island. So we do have a lot of very cool organizations and academic studies that are pulling together some really good infographics and data so that we can start to understand these issues. This one is, it's developed from a study, but also from the Ocean Cleanup and Grid Ardenau, which are a UN supported data group. They have a lot of really good infographics on plastic on their website. And this shows here that, highlighting the major shipping areas, the major fishing areas, floodplains, and other known coastal inputs for plastic. But ultimately, we really don't know anything about the entry points. We really don't know much about river inputs, and the fluxes at river mouths are largely unknown. We do know that it's estimated that over 2/3 of plastic has thought to have already sunk to the seafloor. And we know that it accumulates in subsea convergence zones and canyons, and also at the surface. And so this very nice study looking at microplastics, we can see that because of the hydrodynamics of the ocean, plastic is ultimately accumulating in the gyres. And it's not just the Pacific Garbage Patch, there is essentially a garbage patch in every gyre of every ocean's gyre. And there are many models that have been developed with varying levels of complexity. And just to show you this one here, I mean, I'm not clever enough to make the GIF animate on this, but if you go onto their website, this is an example of some free statistical modeling code that can be applied to floating particles, and moving particles, whether that be fish or plastic particles or other sources of pollution. We can, really model hydrodynamics in quite a lot of detail these days. But ultimately, we're looking towards development of optical sensors and high resolution imagery, which will be delivered on a variety of platforms, such as ship-based technologies or handheld technologies, buoys, aircraft, satellite-based sensors, and these will all be aligned with a network of in situ observations, reports from volunteers, from scientists, ships of opportunity as well, to help us develop data and calibration and validation of remote sensors so that we can monitor the spread of plastic pollution and other marine debris in much more detail. So just to consider things from a policy perspective, as monitoring is embedded in policy, is we need to be able to monitor things and in order to manage them and understand what the best practices and technologies are. We've been researching plastic for decades, and the first workshops highlighting plastic as an issue internationally were in the early 80s. And NOAA has recently hosted the 6th Marine Debris Conference to promote response and education, as well as using guidance from the Honolulu framework, which was developed to help countries develop national action plans. Plastic has been addressed under littering, under MARPOL for ships for a long time, but as with many other regulations, compliance and enforcement remain significant problems. They have recently developed an action plan to specifically address marine litter from ships, and they're also working with the FAO and other groups to try and address fishing gear in more detail. The Basel Convention now has binding measures to address transboundary movements of plastic, and the Stockholm Convention and the Strategic Approach to International Chemicals Management are some of the international binding conventions that can be applied to some extent to the associated chemicals that are found in plastics. The GPA is one of the the only real international body that can be utilized to address land-based sources of pollution, but there is no international institution that has a focus to coordinate efforts on plastic pollution. Although recently we did have the Global Partnership on Marine Litter has been established as a temporary ad hoc expert group. And through the Regional Seas programs, which I'll touch on in a moment, can be used to address land-based as well as ocean-based sources of pollution. We have seen plastic bags has been the most internationally applied policy initiative. Taxing and bans on bags are now in over 70 countries, which gives us a positive example of how policy can work. And we're seeing a big reduction on, so one study found a reduction on plastic bags accumulating in the seabed in the North Sea. However, a big hit was in 2018 when Japan banned waste imports, and they've supposedly imported over half of the world's waste over the years, and now there's millions of tons of plastic with nowhere to go. And so it's really forcing higher income countries to consider their waste infrastructure in country more seriously. So the Honolulu framework provides ideas for countries' management plans. It doesn't specifically set targets for countries itself because it says that they have to develop and assign those targets themselves. It doesn't address solid waste management, as it leaves that to other existing organizations. And it also states that producer responsibility is beyond their scope. However, it does advise on monitoring and research requirements for the national action plans. And it advises on monitoring regional and national hotspots, distributions, population level impacts and impacts of fishing gear on species and coral, degradation of plastics and accumulation in sediments, pathways of exposure and bioaccumulation, the potential of pathogens and harmful algal bloom transfers, monitoring indicator species and economic impacts, as well as research into the monitoring of new technologies and biodegradable and sustainable polymers and their relation to microparticles and plastics, and also looking at removal protocols and life cycle analysis of waste management and disposal techniques. There are various ambitious targets to reduce litter by 2025 in line with the Sustainable Development Goals, but these are unlikely to be met, in all honesty, is the general feeling now that we're creeping up to 2025 in COVID times. But yeah, there is a lot of international discussions towards having this international agreement and potential body to help coordinate efforts. One of the, oops, a bit too quickly there. One of the efforts that have been made internationally towards universal methods for monitoring plastic has been this paper published by Gasamp in 2019. It clarifies physical, chemical, and biological characterizations and definitions, and it also gives policy relevant aspects. As you can see from this little diagram here, it gives you an idea of what sort of questions you want to ask with a policy perspective. Where do you want to look, and how do we measure these different parameters, these different areas in the ocean? So it really looks at methods for monitoring the shoreline, sea surface, water column, and seafloor, but from both a citizen and academic science perspective. It also gives an overview of monitoring strategies and sample processing for microplastics in water and sediments, with a range of spectral and fluorescence techniques. And it also gives a nice overview of biota as indicators for monitoring, which is very popular. And this nice diagram here shows how, if you're going to consider larger species, it's usually larger pieces of plastic and risk of entanglement to be concerned about. And looking at smaller species, you want to be considering perhaps more microplastics, or perhaps even the macroplastics floating, which is what I'm also doing. And yeah, the influence on the habitat is really that sort of aspect. So whether that be birds or fish or plankton, it does give you a nice overview and a lot of references to academic papers and studies that have done this. So the regional seas conventions are the most active existing mechanisms for addressing plastics, monitoring and mitigation, and they're largely supported by academic research. So these, as you can see from this map, there's 18 regional seas conventions, and they have varying levels of conventions in place and action plans that they're progressing. For example, the Mediterranean Strategic Framework includes legally binding measures, whereas the regional action plans for the Baltic and North Atlantic are built around a set of fundamental yet voluntary principles. And similar to the G7 action plan, they propose a series of regional and national actions to address land and sea-based sources, and prioritizing removal actions and education, research and outreach. And also in this, the Pacific marine debris has been identified as a priority area for their pollution management. So how are we all getting on with this? I really recommend everybody reads this Breaking the Plastic Wave overview, funded by the Pew Charitable Trusts. They've done an extensive overview of our pathways to stopping marine plastic pollution. And as you can see from, oh, sorry, I've done it again. Here we are. As you can see from this top graph, if we were to enact all of our current commitments and technologies that we currently have in place, we would only reduce the amount of plastic leakage into the ocean by 7% over this is expecting to triple in the next couple of decades. And we're barely going to dent that with the actions that we're currently taking. They do, however, give us some hope and say if we enact a complete system change by investing in all available solutions, and it gives a really nice overview here of how we're really needing to invest in substitution, reduction, then looking at recycling and at absolute last resort disposal, and there will also be obviously some mismanagement still. But they suggest that we have the ability to reduce our plastic input into the ocean by 80% by 2040. To do this, we need to eliminate all avoidable plastic products. We need national policy development and enforcement. But ultimately, policy is very slow, and we really therefore need industry leadership to demonstrate best practices, producer responsibility, and sustainable life cycles. And education and change in behaviour is obviously also essential for these processes to work. So overall, we do need to invest in the circular economy, but to do that, we need to know what circular is. We need to invest in national monitoring and action plans, and we need to address the whole plastic life cycle, not just for plastic itself, but also for alternative technologies and solutions. We need to support the waste hierarchy shown here, which is, at the heart of the EU directive, and supporting prevention, reduction, and then recycling and recovery, as the whole circular economy is being criticised for focusing on recycling and perhaps using more additives to plastic as a scapegoat to then invest in waste to energy processes, which is just not circular. So yeah, ultimately we need to develop industry mechanisms and global standards to really consider the use, design and life management of products, which is what we're looking to do with some of the special interest groups we're working with some of the companies we're working with. I've also started working recently with a company called Sycamore, who want to provide a funding mechanism for solutions to plastic problems. So yes, thank you for listening, and I look forward to carrying on these discussions. Please get in touch, and I look forward to the Q&A as well. Thank you.
Thank you, Stephanie. Definitely food for thought and quite terrifying in places. Lots and lots of questions coming up for our panel discussion at the end. So continuing somewhat on the theme of plastics, but also on novel monitoring technologies, I'm going to finally hand you over to Phil Johnston, who heads business development for Autonaut USV. He's worked at sea for many years as an offshore environmental consultant and is going to talk to us about using Autonaut ASVs, correct, Phil, for the ocean cleanup.
Thank you, that's grand. So we just share the screen, hopefully that will go smoothly. Nope, not gone smoothly. Okay, is that okay? Okay, that's a nod. Great, well, moved on already. But no, thank you for that, Bev, and thank you to Stephanie as well for setting up this presentation beautifully, really. So that was fantastic. And yeah, the ocean cleanups get a lot of interest, and this presentation is on our role in it, really, which is using fairly novel technology, Autonaut USV, uncrewed surface vessels, we call it now, to help monitor it. So this presentation will run through mainly our role in that, and I guess to continue the theme, it's about monitoring, so monitoring pollution, monitoring the oceans, ocean plastic as pollution in the far ocean offshore. So, if it needs an introduction, the Ocean Cleanup is a very ambitious project to remove that plastic that's already there out in the far offshore, out in the Pacific Gyre that was name checked earlier, and also quite large projects, and not plastics, not the macro, not the micro stuff. So it's the stuff at the surface. Now that stuff at the surface is very prominent, and it's got a lot of attention from this idea of a Great Pacific Garbage Patch, which might not be the island that you kind of have people in mind, but it's still a significant concentration of this human waste out there in what we regard as should be pristine wilderness. So it's been attention grabbing, and it was founded by a guy called Boyan Slat, who was very young when he came up with the idea. It's a bit of a Dutch wonder kid. He calls it a kind of a high school project that spiraled out of control. But I think it had that kind of kudos. It had that feel of a solution, something everyone can get behind. And it was also very physical. It was a very kind of clear, practical way of like, yeah, we can take out this huge barrier scheme, which I think this first iteration is about 600 meters from tip to tail, and a U-shape, sort of a Pac-Man kind of arrangement, and put it out in the ocean. It would stay out there for weeks and months was the concept, and it would physically scoop up that plastic at the surface. Now, I'd be keen to look back in the Q&A about other approaches to addressing plastic, but this kind of really caught the eye. I think it was a TEDx that really set it off. And we can, I don't think I need to overplay the impact of plastic is definitely outlined, but the images of turtles being caught was really kind of galvanized public momentum. So the aims of the project, this was a couple of summers ago, where the system, which was called Wilson 001 with some affection, was put out for testing, and it was put out in the harshest environment, the way out there in the Pacific, a couple of miles out of San Francisco and on the way to Hawaii, with three aims really. The first was to understand the behavior of the system itself. So putting this very novel technology out to sea was a big punt. How is it going to interact with its environment? How is it going to collect the plastic? How's it going to move? Big questions that could only really be answered by just doing it. There was modeling, there's preparatory tests in the North Sea and so on, but this is a big move. So we had a role in that, the autonomy. And also a key part of it was acutely where, when you're putting a novel technology, what's its impact going to be? If you're putting something to collect plastics, big question was, well, is it going to collect other things? Is it going to collect actual living marine life? So that was a key push to study that and to see what effect would this barrier have on that. Would it be entirely passive, and maybe it become its own ecosystem? And also just to acquire data and an understudied area. The Pacific is a huge amount of blue, but it's not that well studied, really. I think it's fair to say, certainly compared to other areas, coastal areas or terrestrial even. So that was a pretty strong aim as well. So three big aims, and to do that, a lot of technology was brought to bear. And this is where my passion. But Autonaut was really just one of those. We had had aerial, so UAV overflying to scan down and look at flights. They'd previously done conventional planes overflying to assess the problem. There were dye tests. There were GPS drifters in the ocean as well. Passive acoustic drift buoys, which was part of the SAGE program. So SAGE is the parent company of Autonaut, and also visual marine life monitoring. So it was well supported. There was a Maersk conventional vessel out supporting these trials for the time it was out there, which is over a period of many months. And they threw a lot of technology at it to try and understand the environment through all these systems. I think it'd be interesting to look back to the technology, that's used to monitor the plastic, and also, of course, the solutions, plastic potential solutions for the project. But there's a lot of data generated. Unfortunately, I can give you a snapshot of that data later in the presentation, but that's all in press and will come from the ocean cleanup in due course. So to focus on our part of it, you have to excuse the cute GIF here. It was called Eve, and a nod to a Disney film. So that's my attempt at trying to be young again. It's a beautiful boat. It was really pride of our fleet. It's this wonderful ocean cleanup color, and it's a 5-meter vessel, so it's only quite a small craft, but it's ocean tough. It's ocean worthy. It's designed to go out there for many weeks and months, and through the series of missions that I'll show you in a minute, we really proved that. It's wave propelled, so you can see in the lower slide, these passive foils are very simple, but they just push it along. They're just enough to use the chop at the surface of the ocean to push it along, maybe up to 2 knots, maybe up to 3 knots on it. When it starts surfing, it can go a bit quicker, but over a period of a mission, it will go about 1 to 2 knots. And it's got solar panels on there as well, a battery pack. So you put it full of sensors, and you've got yourself a data collecting platform at the sea surface for endurance, which it's been a bit of a game changer in recent years, because you're taking pressure off or availability of research vessels. So that's Eve. We were very proud of that one. But what we were really proud of was the missions it did for the ocean cleanup. So you can see the map there where we're at there in the Pacific Gyre, and where the conventional vessel ocean cleanup was out there to deploy its tests. And the system, of course, it's way out there. It's a long way out there. And Eve was in the first instance, it was actually another USV called Isla for the first run at it, and deployed from the vessel, and then it remained at sea. 10 days, working up to 20 days. And then when we redeployed with Eve, we got up to just shy of 50 days. Actually, it's 49.5 days, and then we kept some bits and bobs going after that. So we were pleased. That was actually a milestone for us, reaching that 14.5, 50 days mission, to really prove the concept of, can you put a USV out there for that amount of time? And of course, the idea was, if you put the ocean cleanup barrier system out there, the point is that would be out there for weeks and months. So if you've got an accompanying USV to be alongside it, be its buddy, you can monitor the system. So that was a key part of this concept, and that starts to come through. I'll demonstrate that in the next slide or two. So you've got, what was really exciting on the technology side of it, this solution was the idea of uncrewed, I won't say autonomous, uncrewed systems out there cleaning up the ocean on our behalf. So that got a whole lot of interest. It's probably worth a detour on autonomous uncrewed, because I've started to ban myself using the word autonomy. These systems at best are as smart as they need to be to do the job. So they don't need to be, killer robots making decisions. They're really pretty passive tools just doing a job. We can pre-program them, and we can overview them by satellite comms and tweak their mission plans by all means, and make sure that they're safe. But actually, we put them out there, they set them what their tasks, and off they go and do it. So I'm not averse to using a bit of ocean robots dazzle, but actually at base they are useful, very useful tools that are as smart as they need to be. So moving through the first task, and when we were first approached by the ocean cleanup, this was the main idea. They wanted something to have eyes on their system, and you can see this slide on this image on the right here. It's a big old barrier. So having something on the perimeter of it, going around and inspecting it with cameras, was the big driver. That took a sort of turn as we realised actually we're getting more interesting data. We're beginning to see in real life, as you'll see shortly. But first of all, it was really asset integrity inspection, and to do that we had to get the USV close in, and this was a big breakthrough for us. This is a lot of confidence. You can see the vessel in the background here. If you can see my cursor in the background supporting the entire mission. We were able to remote control our USV and get really in close for some close pass stuff, which we were very pleased, within a few meters, and keeping that control of the Autonaut. And that would do sort of two modes really. One would be very close inshore, close pass to the barrier to inspect it, get cameras underneath it. The real concern was that this net here that you can see suspended here, fine mesh net, would tear. There's a worry that would tear, and the Autonaut would be there in this beautiful clear blue Pacific waters to sort of inspect that and see that. And that video was relayed in near real time to the vessel over Wi-Fi. And we also spotted some wildlife, so it became a bit of a marine life monitoring device in itself, in some close passes with wildlife, which congregates around big entities out in the Pacific at the surface. And obviously the demonstration of a marine life that was out there. Now it's often asked of me, is Autonaut vulnerable to being snagged? And in the early days it certainly was. Now we have a couple of mechanisms, and we've designed the floors in such a way that it removes itself. We sometimes notice it, but it generally doesn't get snarled up, and that wasn't the problem in the Great Pacific Garbage Patch, so it was helpful to give us a little confidence. So that was became a bonus, it became a real interest as we were getting eyes on the actual pilot fish and so on that were around the system. But there wasn't a great deal. I think it's one of those things about the Pacific Ocean that there's not, it's not full of life as you might expect. There isn't that much of what these congregates. Obviously, a big question was whether it would be impacted by the cleanup system, and that's the sort of debate. But the ocean cleanup has been fairly confident in putting out there that no, it's pretty passive. It's not quick, and most things can get out of its way, and it's not going to affect population level disturbance. The wind and wave. So we were collecting a lot of wind and wave data and that assisted the hydrodynamic modelling of the cleanup system. And there'd been a lot of work from the ocean cleanup side on that, using sort of wind models, GFS and CFSR at the SIS site, and sort of open source wind models that they are. Because you're a long way from measurement, boys, in this area, a long way. So to really understand what the Pacific Ocean was doing in terms of movements, and in that what the cleanup system would do, would it act like a Pac-Man and chase plastic down, or would it actually sort of sit back and plastic would come into it? Were kind of fairly major concept of operations questions, which can only be understood by getting these information. And of course, I'm sure there are oceanographers in the virtual audience, and then probably amongst the panel as well, that will understand it much better than I will. But surface transport on an ocean is really tricky to pin down. You've got this concept, this phenomenon of Stokes drift, which means the the vortexes and the swirls of it that move around make it extremely difficult to pin down. So estimating that with was one thing, and modelling was one thing, but getting data from autonomous vessel was a really neat way of getting data from up close and personal position. I should say that the asset integrity monitoring was one element. We found ourselves the Autonaut was switching out to do far field measurements. So increasingly we did our science a little bit away from the Autonaut, from the ocean cleanup system, and that played well for our operations, because in daylight we could go close in, and at night time the Autonaut could go into a further position, further afield, and collect data in a far field perspective. We also gathered oceanographic data, so fairly simple stuff, but useful stuff nonetheless: temperature, salinity, conductivity, and chlorophyll. And that was compared with existing data, and of course, it's informing what might be out there in terms of marine biology. And again, comparison to the nearest system measurements, which were fairly minimal. We also had measurements on the supporting vessel, which helped correlate. But one of the nice things about having an autonomous platform, uncrewed platform, I should say, is that you've got data at remove. It's less contaminated. You're away from the vessel, so it's a bit more pure. Obviously, there's a lot to prove in that. These systems do need their proof from that sort of that high bar that science sets. But we were pretty pleased with it. What the data actually shows is yet to come out. But we got it was about right. I think it's fair to say that's as far as my scientific confidence will take me. But also you can sort of see a few spikes here which indicate that are you passing over a front, or perhaps there's the cleanup system itself is beginning to change the dynamic in the ocean around it. But that will come out in due course. Should also stress that this is just sample data, so a full data set is on the way. An ADCP, this is a really big sensor. This came through as a development with Nortec, who have been really supportive of it. And I defer, anyone interested in this would definitely get in touch and put them through to Nortec, because the idea of an ACP, which is measuring the ocean currents, measuring it from a USV's perspective from the surface looking downward, has become an area of real interest, because it's, first of all, you've got to address a few barriers, which has been a lot of work put into it. Motion correction of a USV mounted, well, any kind of vessel mounted ACP is significant, and of course doing it from a USV. And of course our USV is fairly in tune with the ocean. It's wave propelled, so it's got its own fairly distinct motion itself. Also, you've got to pick out the interference, so in terms of data noise, and from our point of view, the restrictions on payload. It's quite a heavy system from our point of view for power and space, but we integrated it into the ILC here on the deck, and then latterly in a more integrated way. And ultimately, what we ended up doing was relaying that data back. So USV was at remove, collecting this big acoustic data and sending it back to the conventional vessel, which is a real nice breakthrough, and something we're really keen to pursue. And I think I might be wrapping up a little bit early, but that's okay. We've got a good Q&A coming. I think just a little couple of updates really on the ocean cleanup program. One is since this mission, they've introduced a river cleanup system, or I think maybe more than one now, maybe a few of them. So they've been deployed certainly in the Far East and to some fanfare, and there's been other systems like that, but collecting a real drive to collect the plastic closer to the source, which is of interest. But it's the ocean stuff that catches the attention. Again, it's that link to the pristine wilderness that has really caught the eye. They've also brought some plastic back from the ocean, so not insignificant at all. These were trials, but everyone's very very thrilled to recover some actual ocean plastic in a fair amount too, enough to produce a product which is now available in a limited few, but there'll be sunglasses, very beautiful sunglasses, which is Boyan Slat's kind of trademark. So I had a launch of that recently. Mine is still in the post, but otherwise I'd be wearing them now. But that's been really nice, and I think it's been easy to be cynical about ocean cleanup. There's been reasons to kind of a little bit of a backlash, but I think it's that kind of movie star cachet that Boyan himself certainly has. Is kind of got that charisma, and he's got movie stars on board, having the product out of it, and that link to the kind of great blue has a real galvanizing effect. My take on it is that there may be other efficient ways of doing it, and Steph will speak to that. We'll come out in the Q&A, but there's not been David Attenborough and a few notables aside, it's really given a focal point to push policy. Governments have taken note, industry's taken note as well. So I think it's really worthy to do, and we certainly look forward to future missions. Thank you.
Thank you very much. And if I can ask my speakers to unmute, that'd be great, so we can have a Q&A, and I'm sure there's going to be some really good discussions. I just wanted to kick off really with the question about the technologies, because you all mentioned the technologies and the modelling and those kind of techniques. And it's really a twofold question. My first kind of question I'd like to ask is, some of these methods, techniques, technologies are quite advanced. And some of the problems we have are not in the developed countries, they're in the developing countries, in the developing world. Steph alluded to that. The first kind of question is, how transferable are those technologies to those countries and those methods and methodologies? How can we kind of transfer the knowledge and the technologies so they can be used where they need to be, is my final point one. And point two is that without a driver, so Paul talked really clearly about the EU framework directives, and hopefully we still have things like that in the UK. Phil, you've got it's a big commercial kind of project. Obviously the garbage patch is not in an area of any country's jurisdiction, or not solely in a jurisdiction, so you don't have that regulatory driver. And Steph mentioned there's no international frameworks. So without that incentive, what comes first is my question, I think. Is it the monitoring and the measurement modelling first, or is it the regulation first? And so what do you perceive is the best way around? So I'll open the floor. Paul, I don't know if you want to go first. I'm looking at you on the corner of my screen.
Sure, I'm happy to kick off. I can, I'll talk from my experience in my industry initially, and then I'll try perhaps to broaden that out a bit. But from the modelling perspective, there's absolutely no barrier to those being applied and developed in other less developed worlds. Now, you need data to underpin and calibrate and therefore have more confidence in your models, and so sometimes that is perhaps where there's some sparsity of information. If they are expensive data collection programs, some of those the modeling studies that we do tend to be 75% of the cost is on collecting the data, not on the model build. But you can build a model and use it with only limited data. You have to recognize the limitations that come with that, but it doesn't mean it's meaningless. And I mean, there's a great quote, I can't remember who said it, but all models are wrong. They're all wrong because they're representations of the real world, but that doesn't mean they're useless. And as long as you understand the limitations and what it can and what it can't do, models can be used effectively and continuously then improved upon. And there are some great modelers around the world. They're not just focused in developed nations. The modeling community that sort of some of the groups I'm in, there are people all over the world that are in those groups and getting that experience and skill set to be applied. And a lot of studies are also funded by things like the World Bank and so on to enable perhaps more experienced modelling communities, let's say, or people with more resource to undertake studies, not just in their own backyard, but around the world. So I think there's no barrier from my perspective. I think things continuously can improve with, as I said, as you collect more data and more information that underpin models. But in answer to what comes first, I think they do go hand in hand. I mean, the legislation in the UK with regards to water quality has really pushed that investment, but it has gone hand in hand, I would say. So, you know, water, as with any organisation, there's always a pressure on funding. You know, no one has a bottomless pit of money to spend, and there's a lot of pressure on spending that wisely. So water companies would have been investing anyway in models to better understand the operation of their assets. The drivers perhaps have come on the environmental side that have then enabled some of those tools to be slightly re-engineered or reapplied for different elements. So I think they go hand in hand. The legislation is what pushes people to do the things that perhaps they wouldn't need to do without that there, I guess. Everyone has whether you're a private profit-making company or an NGO or a charitable society, you still got to manage your funds.
Great. And so, Steph, you've got some experience in kind of Indonesia and the developing world. What's your take on?
I think, yeah, as Paul said, there's not really any barriers from a technological and academic perspective for us to be monitoring these areas. I think but I've got a little bit of just different perspective, and I think the monitoring comes first, because I think we get the information through environmental interest, and we've had monitoring data highlighting plastic for decades, but we haven't had any specific international regulations to address plastic. And we're really, even what we do have really only addresses the end of life. It doesn't address any upstream processes with the production and the chemical additives and things like that. So I think policy is very much lagging behind our monitoring and technology capabilities. When it comes to low and middle income countries, they are suffering the worst. As I alluded to in my presentation, it's not all their responsibility. There's very difficult socio-economic constraints with their countries and their governments that prohibit them to invest in waste infrastructure. They're not really getting a lot of help externally to that. There's not really many international funding mechanisms. I know the World Bank did fund a rapid survey of Indonesia on plastic pollution. And that, in my opinion, told us enough that, the river in Jakarta is very well known to be one of the most polluted rivers in the world. You can't even see the river for the trash. Do I think we need to be monitoring more in order to address that? No, I think we can start addressing the removal of that. I think monitoring will go hand in hand in that to perhaps look at what is in there, where it has come from, either whether that be by just identifying the branding and start highlighting more that these international companies are, have no responsibility on this, on the end of life of plastics, which is a big gap in sort of monitoring and regulations and standards, is that they produce all this stuff, they make a lot of money from it, but then they have no responsibility to make sure that gets collected in any way, or where, where it gets exported to countries with no regulations. So yeah, I think as Phil was talking about the ocean cleanup, they have a very interesting area there where they're trying to manage the high seas, which obviously has no policy, but at least there's and I know the ocean cleanup has had a fair bit of criticism, but at the end of the day, they're one of the only projects addressing trying to address the plastic in the ocean, which we know is going to get a lot worse, and we're still not investing in removal technologies to any great extent. We're looking at rivers more now because that's a great source. We know that's a great source, and yeah, it's about trying to pull people that are manufacturing this stuff internationally to the waste infrastructure management, and trying to find out who's responsible to push end producer responsibility, and get them talking and investing in waste infrastructure and collection facilities. But then remote islands, again, on top, are even more of a challenge than low and middle income countries, because they've got nothing there, but they're obviously, the environment there is under a lot of pressure. And I think technologies such as the ocean cleanup and these remotely operated vehicles and whatnot can really help bring us to some solutions for these small islands where we need international cooperation and investment to go and clean these places up, and as well as preventing everything from source.
Thanks, Steph. So Phil, you know, before you answer that question, I'm going to add a third part, which Steph alluded to, which was who should be paying for these cleanups. And you know, I think, Paul, your comment about seagulls made me chuckle, because, you know, with it, you can put some responsibility on certain industries, sectors, etc. if you can prove that it comes from them. You can't put any liability on a seagull. A seagull is not going to pay to clean up its E. coli. So I quite like to get into that debate. And Phil, if you're happy to answer the other part of the question, then obviously the ocean cleanup is a really uniquely funded mechanism. But is that right? Is that the way it should be funded? I think is the kind of question we want to debate here. So Phil, over to you, please.
Yeah, I'll try. I'll do my best. There's questions stacking up there, but in terms of, I really get the ownership. I think is a really interesting point here. In terms of the technology, which I think is where it started, was I noted down. You know, the technology is there. You know, I mean, obviously we're always talking about the new stuff, the stuff that's coming through, but it's, you know, aerial drones, whatever, you know, whatever works. Really, it is there, and it's relatively cheap. I know Paul mentioned it. You know, relative to modelling, maybe not so much, but it is there, and it is transferable. You can put it into position. I think that's been, you know, a huge change in the last few years in ocean science. You can put sensors where you want them, you know, but that's not the point. The point is what questions are you actually trying to ask? You know, we're probably drowning in data, and how to get it. That's not the problem, I don't think. It's deploying it in a smart way that you answer the questions you want to ask. So that's my point about technology. I should also mention the ocean cleanup was funded. I think I neglected to say that primarily funded by government. So I think the Dutch government have put a lot of money in. And also philanthropic. There's been a few high-end donations. Crowdfunding has been a part of it as well, but I think that, and also industry support, which kind of brings around, I think, to the ownership element, which is the key here. The cleanup element, and it goes to, you know, many of us go on a beach clean, and we now much more less embarrassed to, more proud to start picking up, be seen pick up a bit from a beach. That's of ownership to me. That's a kind of like, no, it's a drug problem and I'm taking responsibility for it. Tracking that back to the source is where it gets more challenging, and that's obviously Steph's area. But the branding thing was what really caught my attention. As we can see, it's you know, it's a bit litter that is linked to a certain company. So my question was really for all of you was how is that going to come through? Is it responsibility of the companies, government level to public? I think that's surely the nut to this.
Did you want to come back before I hand back to Steph for her?
Yeah, I mean, there's a
thoughts?
couple of things there, and I'm getting a bit old these days, so I'm quite forgetful. But I did want to say that on one of the points that Stephanie made was definitely a valid one about the drive and the legislation. So within the water industry that I was talking about, it's a very regulated industry, and the water companies are there funded by our water rates, by, you know, the people that they serve to do a specific job, or two jobs really, to clean up our wastewater and dispose of it, and to treat and provide us with drinking water. And they're regulated, and there are standards there that they need to achieve. And so they go about trying to do that as efficiently as they can, because they Ofwat controls the spending, so to try and keep water rates low. So in terms of ownership and who's the polluter in that case, well, is it the water company? Well, it is if they're failing to do what they should be doing. But as I said, it's ultimately humans are producing it at source. And coming on to the plastic side of it, I mean, water quality is one thing. You know, I've been on a couple of beach cleans and you see all sorts of horrible stuff near and outfall, and wasn't the water company that put all those cotton buds and tampons and stuff into the sewer. They're trying their best to clean it up. I'm not here to defend the water companies. They are my clients, but they're not all squeaky clean, but they do their best, I think, on the whole. So, you know, in some cases it's awareness. Education is perhaps the wrong word, and that is increasing, I think. You know, I know my kids at school are learning about what not to put down the loo, and they come back and tell me and so on. And so that's really good, and it works. You've got to get it at that sort of fundamental level. That's only part of the issue, isn't it, I think? And in terms of the plastics and branding, and I was getting quite depressed. I said to Stephanie, I was worried enough with everything else that's going on in the world, and it's not that I wasn't aware of the issue with plastics, but just the scale of it and the you know, we can do everything. There's lots of things that we can do in our society, both from a individual point of view, and raising that awareness is one thing, and trying to do our bit and not buy a plastic bag and use plastic, you know, bags for life and so on. The producers, really, it comes down to the producers. And I think, you know, supermarkets as an example, it's at the edge of my knowledge here, but they can do more to reduce the packaging. And I think there's a lot of, I don't have any solid evidence, but claiming things are recyclable, I think, is overstated. If that's the right word, quite often. And you mentioned, you know, there might be recyclable once, or it might have 5% of the material is from a recyclable source. So producers, supermarkets can do much more, I think, on packaging, and they'll only do that, I think, under pressure from either the government through legislation and or social pressure through social media. And I think both of those things are starting to happen, by encouraging some of the stuff that came out yesterday on the sweetest stuff that Boris Johnson's announced. But I think there's more that could be done. But I feel like I've gone off at a rambling tangent, so I'm going to hand back to you.
No, I think you made some really good points there. And I think my feeling, going back to the sort of original question of the responsibility, is it us as the consumers, is it industry, is it governments? I think everybody has to address the problem. It's everybody's problem equally. However, for decades, the blame has been placed on the consumer. It's our responsibility to recycle. It's our responsibility to make sure we buy the right products. But you go into the supermarket and there's not much choice to buy something that's not wrapped in plastic. So yes, supermarkets play a really big role in this. And I think that's where public engagement could do a lot more. I loved that there was a protest of a while for people going into Tesco's and leaving all the plastic on the aisles and stuff, or on the checkout, which I thought was really great for raising awareness. But it's a conspiracy, really, because it's, you know, that message has been driven for a very long time about recycling, but we still recycle less than 10%, and that's not my fault. For I put everything in the recycling, but over half of it is getting exported to Asia, where it's polluting the environment. Yeah. So it really comes down to the lack of effort and investment from governments and industry. But ultimately, we're dealing with the oil industry, is what it also boils down to. And for many years, we have seen them, politically lobby and push back solid science, so that they can carry on their industry. And I feel that, you know, they're doing exactly the same with plastic. They are investing heavily in waste to energy, and it's a greenwash. But it allows these companies to keep producing mass amounts of plastic, and then producing fuel at the end of it, which is, you know, it's still not renewable. So yeah, and I think you made another interesting point about now we have this problem of so many different, I mean, I go into the shop and I see bottles that are made from 100% recycled plastic, and I'm like, I'm pretty sure you can't physically do that. I'm pretty sure that's a highly illegal bottle if that's the case, as far as I'm aware. And so we have all these standards that we now have to worry about for alternative products and the waste stream, because we're coming out with all these compostable items, which is great, but they're just going to landfill and causing more of an issue. So yeah, but what the Ocean Cleanup did that I was very impressed with their sunglasses was that they worked with DNV, a very, very credible association for standards, and they developed a standard for proving that the ocean recycled plastic product that you have has come from plastic that was collected in the ocean. And they show, I think the procedure is they show, you know, photographs of every step of the way, how it's been transported, where it's gone to, how it's been processed, and that really needs to start being pushed in industry. But yeah, I'm seeing a lot of different standards pop up. People are wanting to certify this, that, and the other, and so yeah, we need to be careful that that doesn't, you know, go really unregulated, and we just end up with more products made with a whole bunch of different things and additives that are ultimately just going to be burned or sent to the landfill. Yeah, I don't know what my point really was there, but
I mean, I'm reading a lot of positive things here. I don't always feel that way, I know, but you know, it wasn't that long ago where it was a kind of something should be done attitude, but no one actually did anything really. And it was a bit, you know, it was quite a few kind of, you know, earnest souls would collect, you know, pick up litter and try and recycle it as best they could, but it wasn't remotely cool. And I think there was an element of you know, those images of turtles and things with wrapped up kind of collectively shamed people, and then it changed to like something can be done and we are going to do it. And what we're talking about now is, can we do it more efficiently? And that's been a pretty major step change, you know. I think Stephanie, to bring it down again, you know, a lot of positives there.
Bring it down again.
A lot of positives there, but yeah, I think the danger of greenwash is significant, isn't it? You know, it is such an easy thing to, you know, pick a bit of litter and Instagram it, and you know, aren't we proud of ourselves, and actually, you know, carry on with our consumerist lives. But I hopefully there's room for.
Yeah, I mean, I did a bit of very simple math to try and understand, because you read all these numbers, there's millions of tons here, millions of tons there. I tried to give myself a bit of perspective over, you know, what are we doing? Because I do a lot of beach cleans. I've done a lot of beach cleans over the years, and I was very impressed with the world's biggest beach clean in Mumbai. One started by one guy, and over 2 years he acquired thousands of volunteers, and they cleaned this beach. You wouldn't believe that people could actually have cleaned this beach up, but volunteers did it. Over 2 years they removed, I believe it was 12,000 tons of trash from this beach on a voluntary effort. But we know that easily 1 million tons a month is already leaking into the ocean, and this is only expected to get a lot worse, a lot quicker. And as we started, the sort of Q&A really was, one of the biggest issues we know is around low and middle income countries. And at the moment, I feel like there's a lot of good grassroots organizations trying to address something, but there is this big issue of there's no waste infrastructure or collection facilities at any sort of scale going on in Asia, other than the waste to X facilities in China, which are also increasing exponentially. And you know, it's one of the few things you see people actually protesting in China over, is the air quality over these sorts of factories. And even in America, along the Mississippi, there's an area known as Cancer Alley, and it's, you know, very socioeconomic tied, because that's why these facilities are built there. And yeah, there's this whole air quality pollution, not just the microplastics that's in the air, but you know, from the production facilities to the incineration. That's what I think scares me, and that's what I think there's a real lack of public awareness around that, which we need, because people have been so great to bring plastic to the forefront and get the international organizations starting new groups and addressing new policies. But yeah, I think we also need more public engagement and awareness around these issues, so that we take it in the right direction, and it's not just left to the government and industry lobbyists.
Right. So we've got about 3 minutes left, so I'd like to leave on a positive note. So I'm going to assume that all of you are going to be submitting papers to Oceanology 2022, when we hopefully will be meeting again in person. So in 1 minute each, what positive topic would you like to be talking about in 2 years' time? Paul, I'll start with you.
Marine renewables, without a shadow of a doubt. It's yeah. Is that enough?
Yep. Excellent. Stephanie?
Well, I'm starting an initiative to try and increase, a citizen science initiative to start growing seagrass in coastal areas around the UK. And I feel that growing seagrass is a lot more productive, or a lot more rewarding and quickly rewarding than planting trees for carbon sequestration. A couple of quick facts: we've lost over 90% of our seagrass around the UK. 0.2% of the world is covered in seagrass, but it sequestrates 10% of the CO2. So it's a really great and underutilized solution to climate change. And I hope to be talking about how successful that will be moving forward.
Brilliant. And Phil, last but not least.
Well, Paul stole my thunder a little bit. I was going to say clean technology. That's okay. I think clean technology more generally. I think there's progress here, isn't there? You know, that we are seeing drive from oil and gas companies talking about carbon zero. Commercially, we are certainly seeing that and benefits of that. We can be cynical about politicians, but these grand statements all add up to promises. So I think hopefully in a year and a half, the conversation will move on. We can hold their feet to the fire a little bit more. Could I just add? Sorry.
Yeah, of course.
Have you got time?
Yeah.
So just to expand on my point on marine renewables and add to Phil's, it really annoys me. It's really frustrating that there's some fantastic schemes, and there's a lot of resource in the UK as a leader in this field, tidal energy in particular, but also waves. We've demonstrated how effective wind can be, and it's taken quite a long time to get there, and it's needed quite a bit of investment. There were little developers going bust all the time because they're just not getting the investment, but there's some fantastic opportunity to really bring tidal power into part of the energy mix, and I think it's frustrating it wasn't mentioned yesterday in yesterday's announcements, but so that's why I'd like to talk about it next year.
Great. Well, thank you very much. Thank you to our audience who are joining us in December. I hope you've asked lots of questions through the opportunity there that our speakers will be answering in due course. And thank you very much to the organisers for letting us have this session today.
Thank you.
Thank you very much.
Thank you all. Thanks.
It's been a pleasure.